Here we go. You guys wanted more limits, and initially I was not going to do this until notes 5, but last night I decided to play with the notes, and I made this notes 4, and then I pushed notes 4 to notes 5. So I put this for me. This is not really for you. This is really for me, so I can know, like, hey, why are we doing this early? So this is why it says Units 1 overview, because we're going to have an exam probably next week. Well, I'm letting you guys know because that on Tuesday. I know it's during lab. That way everyone can spread out. Yeah, don't worry.
Funny joke.
All right.
Funny joke, Rob. Funny joke. I'm not. Are we doing lessons?
No, we're not doing a lesson tomorrow because tomorrow's your lab. Well, technically, should have been the review, but we'll do like a review. All right, don't worry, guys. We'll be fine. Hey, Miss Kyle, don't be mad. Why are you mad? All right, here we go. Miss Montalongo. I don't even know why I said that. I'm recording. All right, here we go. Let's start. So we have an idea of how to do limits. Let's see if we can do all these limits without a calculator. Number 1, letter A. Can I do that limit without without a calculator? We're going to do them without a calculator. Can I do direct substitution on that one? Yes. So do direct substitution. 2 minus 4, negative 2. Over 2 squared is 4 plus 2 plus 2. So 2 plus 8. So this reduces to negative 1/4. Yay or nay? Letter B. Can I do direct substitution for that one? No, because you get a 0 in the denominator. What's up?
You can only not do direct substitution when there's a 0 in the denominator.
Correct.
If there's a 0 in the numerator, it's not.
Yes. So we cannot do direct substitution. So that means we have to do something else. So let's expand it. So I'm going to write the word limit because we haven't solved it yet. Limit as x approaches 3. And then the numerator, the difference of squares, x plus 3 times x minus 3. And on the bottom, you got to be able to factor out, guys, 2 numbers that give you negative 6 that add up to a negative 1. What is that?
3 and 2.
And they're both going to have to, which one's going to be the negative one?
Negative 3.
There we go. What cancels out? What factors cancel out? Now can I do direct substitution? Yes. 3 plus 3 is? And 3 plus 2? So there it is. That's 6/5 or 6 over 5. By the way, when you do a direct substitution and you get 0 over 0, it's going to have a limit. It's going to have a limit.
I'm still confused.
If you get a 0 in the denominator, you can't do direct substitution because you can't divide by 0. And see, if I plug in a 3 directly, 3 squared is 9, minus 3 is 6, minus 6 is 0. You can't divide by 0. Do you know what I mean? Yeah. So, guys, when you do direct substitution, see how on this one, if you would have done direct substitution, you get 0 over 0? If you get 0 over 0, there's something called L'Hopital's rule. You don't know enough yet because that deals with taking derivatives. If it's 0 over 0, it probably has a limit. 99% sure. Maybe almost close to 100%. Cool or not cool? Now, if you get a number over 0, that's a vertical asymptote. You're done. You're toast. Wait, can I say toast? Did I use it correctly? You're like, it just does not exist. It has a vertical asymptote. Look at the next one. Limit as x approaches 2. If I plug in a 2, you get 5 over 0. Can you divide by 0? No, but you got a number in the top, so that means x equals 2 is a VA. What does VA stand for? So because I have a vertical asymptote, that's an infinite discontinuity, this limit does not exist. If you approach from the right side, I think it's positive infinity. If you approach from the left side, it's negative infinity. Does not exist. You don't have to worry about the behavior. For letter D, it's positive infinity from both sides, but you don't have to worry about that. It just does not exist.
So if we can expand it and the denominator is 0, it has a vertical asymptote and the limit does not exist?
If you have a vertical asymptote, it doesn't have a limit. Because the behavior, remember? Positive infinity, negative infinity? Ask me.
So if we can't expand the formula and the denominator is 0?
If you can't do anything with that algebraically, it does not exist. If you get a number in the numerator and a 0 in the bottom, it does not exist because it's a vertical asymptote. That's the definition of a vertical asymptote. Does that make sense, guys? All right. Letter D. It's the same as letter C. So this one does not exist. It does have a behavior. It does have a behavior. The behavior is positive infinity. So either or would have been perfect. Does not exist is fine. Because as I get closer and closer to 2, it goes up forever. You see that squared? If I were to do a table, look what's happening as you get closer and closer to 2. So in the top is always kind of like 5. 2 plus 3 is 5. But as I get closer to 2, let's go from the right. 2.1 minus 2 is 0.1. 0.1 squared, even a smaller number. 2.01 minus 2, 0.01. 0.01 squared, even a smaller number. A number like 5 divided by a super, super small number, it's going to explode the output. If I approach from the left, 1.9 minus 2 is a negative 0.1. But when I square it, it turns to a positive. So a number in the top like 5 divided by a super, super, super small positive number, it's going to explode. So my behavior is positive infinity. You can also type this into the calculator or Desmos, and you can see, that's fine. We can type it into Desmos really quick. So you can see the behavior, x plus 3 over x minus 2 squared. So look, Desmos. F of x equals fraction, and I already forgot, what was it? X plus 3 over x minus 2 squared. See? I bet you I can make a table. Can I make a table? Table. Let's see, what I got to type? X, and then over here, type f of x. Will that work? Let's see. 1.9. Yep, it works. Look at that. 490. 1.99, 49,900, 1.999, 4.999 times 10 to the 6. So look how big it, if we approach from the right, 2.1, 510, 2.01, 50,100, 2.001, 5.001 times 10 to the 6. See, so it's already exploding. Plus you can see it here, x equals 2. Look at that vertical asymptote there. Let's change the color. How do I enter the settings? That's fine. See, cool or not cool? Okay. How do we feel? Sorry for the sign. All right. End behavior. X is approaching infinity. If you spit in the ocean does not rise. Are we okay? So the 5 is the spit in the numerator. The 3x is the ocean in the numerator. Or negative infinity. In the denominator, what's my ocean? What's 3x divided by 2x? Connect this to your algebra 2. That's also a horizontal asymptote, guys. Say it again. Yes, the spit in the numerator is a negative 5. The spit in the denominator is a 4. Does that make sense, guys? Oh, it doesn't make sense then? Okay, sorry. What about letter F? What's my limit there? 0. Why is it 0? Yeah. Okay, but make sure that we know why. Don't be a robot. Because as x grows unbounded, the denominator grows faster than the numerator. So, of course, you're going to be approaching 0. Look, 1 divided by 1, 1. 1 divided by 10, 0.1. 1 divided by 100, 0.01. 1 divided by 1,000, 0.001. Look what's happening. And I know I left the numerator, the constant 1 on this for my example, but it's the same concept. The bottom is getting bigger than the top, so I'm approaching 0.
So when the denominator has a bigger factor than a numerator, it's 0?
When the denominator has a bigger degree than the numerator, it's 0, yes.
Whenever it's growing unbounded.
Whenever x is growing unbounded. Whenever x is approaching infinity or negative infinity. Yes.
So we found the horizontal asymptote, right?
Yeah.
But how do we know if it's going to pass? Like, how do we know that's actually the limit if it can pass in the asymptote?
Well, I mean, you can cross horizontal asymptotes, but you know that's actually the limit because like you can just see it, like the bottom's growing faster than the top. So if you wanted to type it into the calculator and just use like the table feature, 1, 10, 100, 1,000, 1 million, you'll see that the output is going to get closer and closer to 0. You know what I mean? Okay. Are we okay? For sure? Okay. All right, guys. I think you guys are really good at graphs. I think you guys have no issues with graphs. Letter A, what is my limit as x approaches positive infinity for this graph? -3. See, it looks like it approaches -3 there. Letter B, what is it as x approaches negative infinity? 0. It's from this one right here. Put a little arrow there. Letter C, x approaches negative 3 from what direction? From the left. So here's negative 3. If I approach from the left, what is it? Either positive infinity or does not exist. Did I do that right? Letter D, what is it as x approaches negative 3 from the right? Negative infinity or does not exist. Because infinity is a behavior, it's not a number. You're approaching that. You can never reach. It needs to converge to a number. If you don't approach a number, then you don't exist. You just keep growing unbounded. What does that little minus sign in the upper right hand corner of letter D mean? From the left. Yes. So limit as x approaches 0 from the left. What is that? 0. Good job. Good job, nerds. Yes. You don't care about continuity for limits. You just see what you're approaching. So for limits, see how I'm approaching 0? I know that you're undefined at 0, but I'm approaching the y value of 0.
So the only time that it would be undefined is if it's going unbounded, like it's going up, down, up, down.
That what you would say does not exist. Undefined is for functions.
Oh, okay, but yesterday whenever I was doing the delta, you said that to put undefined.
If it's Oh, I did. I thought I told you that for. I'm sure. Did it count it right?
Yeah.
Yeah. So it takes it, but the oscillation one, the oscillating ones. I think the better word is does not exist, but it took it for undefined because technically it's like the same idea. Limit as x approaches 0 from the right. I'm gonna say what? Infinity or does not exist. What about letter F? I'm approaching from what direction? From the left. If I approach from the left, what does it look like? Infinity or does not exist. What about letter G? Infinity or does not exist. All right. Here we go. Tougher ones. This is what we need help on. It's the algebra, really. All right. So write these two down. This is the sum of cubes, a cubed plus b cubed. This formula looks like this. A plus b, a squared minus ab plus b squared. What is that called? Sum of cubes. Here's another one. A cubed minus b cubed. This one starts with a minus, so a minus b. And then all the other ones are pluses. A squared plus ab plus b squared. What is that one called? The difference of cubes. How do we feel, guys? Nothing crazy, right? All right. Before I do anything on letter A, can I do direct substitution? No. Why can't I do direct substitution? Yeah, you get a 0 in the bottom. So I have to use my sum of cubes. Do we notice that that 8 is nothing more than 2 times 2 times 2? So, yeah. Oh, wait. What's up? Tell me, yeah.
Wait, why are you cooking?
Oh, I thought you wanted me to wait. Sorry. So, and how do we, guys, the observation, we saw that x cubed there, so that's probably going to give us a hint there. So here we go. Write the word limit because you haven't evaluated your limit yet. As x approaches negative 2, your a is x and your b is 2. So all I'm doing is this top formula up here, guys. This is why we took algebra 2. X plus 2, close, open, x squared minus 2x plus 4, that's 2 squared, all over x plus 2. I have a product in the top, and I'm dividing. Those are inverse operations, product, multiplying, and dividing. So what can I cancel? The x plus 2's. Now can I do direct substitution? Yes, plug it in, guys. 2 squared minus 2 times 2 plus 4, or negative 2, right? So negative 2, negative times the negative is a positive, so 12. Yay or nay? Yeah. Okay. Letter B. What do I do with that one? Guys, be smart. Or be clever. You don't even have to be smart. You just got to be clever. So, so are you saying we can? No, you're no. Don't square the numerator and denominator, because then you're changing the value. You can do that. Is there? I like that route, but I want you guys. I want you to open your brains. I want you to notice something. Look at that x, and how does that x compare to the square root of x? Look at that 4, and how does that 4 compare to that 2?
Oh, what did I just say? What did I just say?
So, guys, here's what I'm trying to tell you guys. Just because, okay, all your life you've been told a squared minus b squared, those are the difference of squares, and that's the same thing as saying a plus b times a minus b. Guys, it doesn't have to be perfect squares. I mean, I guess at the high school level. But look, this is not a perfect square. It's fine. Square root of x times square root of x is x. 2 times 2 is 4. Yes, it doesn't have to be a perfect square. You can say the square root of 7 and break that down into 7 to the 1/4 times 7 to the 1/4. So, Chop, what are you trying to say? I'm trying to say that this, guys, limit as x approaches 4. You leave the top alone because it's already in like the most simplified form. You can say that the bottom is a difference of squares. Chop, but they're not perfect squares. They don't have to be. Square root of x times square root of x is x. So I can write the bottom as square root of x plus 2, square root of x minus 2. They don't have to be perfect squares, guys, as long as the rules apply. Do we see that? And now that I have it written like that, what can I cancel out now? The square root of x minus 2's. Now can I do direct substitution? Yes. What's the square root of 4? And 2 plus 2? So what do I have? 1/4 is the denominator.
So the goal is always to get the formula in a position to do direct substitution.
With this one, I would when you notice the pattern, difference of squares in the denominator, cancel out a common factor. Could you have multiplied by the conjugate? Yes, like what you were saying. We're gonna do that next with the next one. But I just like this method better. Your method's good too, though. It's gonna work for the next one. What's up?
What if we don't notice the pattern?
Do that. All right. So here's what Fam told me on this one. Can we do direct substitution on this one, guys? No. So we're gonna have to multiply by the conjugate. What's making this harder? The numerator or the denominator? The numerator. So you multiply by the conjugate of the numerator. Chop, what are you even talking about conjugate? Remember when you were in Algebra 2 and you guys were doing complex numbers and they told you a plus bi? Do you guys remember that? No. Relax, we're not working with imaginary. I'm just a definition. What's the complex of a? What's the conjugate of a plus bi? A minus bi. Why is this whole conjugate thing so important? Because when you multiply a plus bi times a minus bi, look, that looks like the difference of squares. That turns to a squared minus bi squared. So you get a squared plus b squared when you were in Algebra 2. But notice that we don't have to mess with the whole middle stuff. I know, some of you are like, I don't understand what you're trying to say. Okay. Here's what I'm trying to say, guys. A plus b times a plus b. No, don't write this down, just listen. If I were to distribute this, a times a squared, a times b plus ab, plus b times a plus another ab, plus b times b plus b squared. Look, I have this junk in the middle. A squared plus 8 plus 2ab plus b squared. Obviously, that's for that one, right? This stuff in the middle is what makes this like quote unquote hard, depending on what you have. But if I have something like a plus b times a minus b, now I'm not trying to insult your intelligence. I know you guys know that's a difference of squares. But look, we can just go right to a squared minus b squared because we don't have to mess with this middle stuff. A times a squared, a times minus b minus ab, b times a plus ab, positive b times negative b minus b squared. Look, this middle stuff cancels out. And we just got a squared minus b squared. Do you guys see that? Yeah. So the whole idea about this, like what can I do to make this simpler? You multiply by the conjugate and you don't have to worry about the middle stuff. Now don't be a robot, don't worry. In a little bit I'll let you guys write. Don't just right now, just take this in, just observe. All right. This is just 1. Anytime you multiply by 1, nothing changes. So don't be a robot. This is 1. Now Chop, why are you multiplying by the conjugate? Because I'm going to cancel all this middle jargon stuff out. Does that make sense? Yes. And then we'll make it easier that way. So check it out. Don't worry, I'm going to give you guys time to write. I just want you guys to observe this. This is like your a, square root of x plus 16, square root of x plus 16, and the 4 is like your b, like over here. So square root times square root, the square root's going to go away. Do you guys see that? So I'm going to have x plus 16. And then negative 4 times the positive 4, I'm going to write minus 16. Because remember, I don't have to worry about the jargon in the middle. all over, and in the bottom, I'm not even going to bother distributing it. I'm going to leave it like this. X plus 16. Don't worry, guys. We'll be fine. And this is all that. Are we still okay? Look what happens to the numerator. What happens to those 16s? The better word is zero out, but you can say cancel out. That's fine. And now because I have an X on the numerator, now I can what? Now you can cancel these suckers out, and X is approaching what? 0. So now can I do direct substitution? Yes. If I do direct substitution, I get a 1 in the numerator. 0 plus 16 is 16. What's the square root of 16? 4, and 4 plus 4? There it is. All right, guys. Write it down and jot down the little steps that we did. Did all that make sense, guys?
Yes.
Well, that's why we're building grit right now.
I heard child make some action about it.
Oh, miss, I just love math, miss, and I hope that you guys love it too. I'm not saying that you're going to be doing limits all your life, right, in your field or whatever, but it's a problem solving, the logic that you're going to take with you forever. That's what's most important. And that's why universities want you guys, because universities know that calculus students are the best. All right, here we go, guys. You guys ready? Ms. Kyle, you ready? Okay. What do you think this limit is right here? You know what? I'm going to do 2 of them. Let's break this up into D1 and D2. D1, limit as x approaches 0 from the right, absolute value of x over x. This is a famous one. It comes out all the time. What do you think this one is? What do you think this one is, Rodriguez? Take a guess.
Wait.
Yeah, what do you think this limit is? What does your intuition tell you?
Yeah, I'm thinking 1. Yeah.
Oh, yeah. How'd you figure out it was 1?
High five. You got that. Zicky's about
No, don't say 0 over 0. That's not 1. If I have y equals absolute value of x divided by x, as long as x is positive, then it's 1. This will always be 1. So here's my graph. Here's 1. And as long as, if you're not defined at right at x equals 0, but as long as x is positive, bless you squared. As long as x is positive, it will always be 1. All right, Miss Cruz, you're next. Oh, that sounded like it's a fight or something. I'm sorry, guys. What do you think it is as you approach 0 from the left-hand side? Think about the numerator. The numerator is always positive because of the absolute value.
Oh, so it's still 1.
Is it 1? What about the denominator? I'm approaching from the left of 0.
Wait, what? Oh, you'll be negative.
So that would be negative. The denominator, right? I'm approaching from the left of 0. So to the left of 0 are negative numbers. The magnitude of both the top and the bottom are both going to be the same because it says x. But the top is always positive. But the bottom is always negative because I'm to the left of 0. So negative what? Negative 1. So how will this graph look? Right at negative 1. As long as x is less than 0, the output will be negative 1. Here's an example of a step or a jump discontinuity at x equals 0. Do we see what's happening, guys? No? Should we talk about it again? Okay. The numerator, okay, let's just pick numbers. If I'm to the left of 0, so give me a number to the left of 0, any number.
5.
To the left of 0.
Negative 5.
Okay, negative 5. If I put a negative 5 in here for the numerator, absolute value of negative 5 is 5 divided by negative 5. Negative 1. So I go to negative 5, bottom point of negative 1. Let's pick another number to the left of 0. Negative 10 or negative 6, whatever the number is. Absolute value of negative 10? 10. Divided by negative 10? Negative 1. Negative 1. So negative 1, another point. Connect the dot. Boom. Forever. Any x value to the left of 0, when I plug it in here, if I say this is y equals, it's going to be a negative 1 forever and ever. To the left of 0.
Yeah, also, this is not
slope.
Well, the slope is 0. Don't say no slope. The slope is 0, right? Slope is 0. It's just horizontal lines have slope of 0. Okay? Every value to the right of 0 is just a positive divided by a positive, so it's going to be 1. So the blue curve is always positive, the red curve is always negative. Is it positive 1 or negative 1? Say it again, say it again.
Sorry, the limit does not exist, right?
Yes. This one here. DNE. Because if I approach from the left and if I approach from the right, they're both two different values. You guys ready for the next one? Relax. It's not even that bad. At first glance, can you do direct substitution?
That's a great question.
No, because of this guy right here. If I plug in a 2 in the denominator of the denominator, if that makes sense, 2 squared is 4, minus 2 is 2, minus 2 is 0. Do you guys see that?
Yeah.
I think I said an extra 2 by accident there, but you guys know what I mean. So I'm just going to take this. I'm going to go limit as x approaches 2 of x minus 2. And in the bottom, is that factorable? Yes. What are my factors? X minus 2, x plus 1. What cancels out? And now, can I do direct substitution?
I get that fraction cancels out. We're going to be adding it by 2 raised to 4 anyway. That's going to be over 0.
Yeah, but I can't have a fraction there be undefined. If I plug in a 0, if I plug in a 2 in there, you'll get a 0 in the denominator of the denominator. So you can't. If any, yeah, correct. Cool. All right, here we go, guys. So actually, I didn't even have to do that limit there. I could have just done just this part. So I'm going to change that for 1 over x plus 1. So now here's what I have. Limit as x approaches 2, 3 to the power x plus sine pi x. And I should have put parentheses in pi x. That's fine. X to the 4th plus 1 over x plus 1. Now I can do direct substitution. They both behave the same. So I'm going to plug in a 2. You guys ready? 3 to the 2 power plus sine of 2 pi. The pre-calc kids just started learning about that today. Thank you, Miss Delgado. 2 to the 4th power plus 1 over 2 plus 1, which is 3. Let's do some arithmetic and figure this out. That is a number. What number is that? Well, let's see. 3 squared is 9. What's sine of 2 pi? 0. All right, sine is a y value. It's all good. Save space. 2 to the 4th power. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Plus 1/3. An improper fraction or a fraction within a fraction. We don't want that. Turn that 16 into, what's 16 times 3? 16, 32, 48. 32, 48. Is that a song? No? Okay. Well, that's the second time I've done that. I'm going to do a song. Keep change, flip. That was dumb. I'll stop. What's 9 times 3? Keep change, flip. Keep change, flip. I don't think that simplifies. Does it simplify? Leave it alone. That's the best answer. This one's okay. This one's better. This one's best. Do you guys already have experience buying tires? Not yet? You guys are barely getting there? Okay. That's how they sell you tires. I'm not even kidding. You go to the tire guy, to a legit tire guy, not like a mom and pop shop. And they go, yeah, this tire is okay, but this tire is better. And guess what? The better tire is more expensive. And then they sell you, they try to get you by safe. Of course, I do agree, safety is important. Yeah, but But for the ultimate safety, this is the best tire. And of course, the best tire is like ×2 what the cheap tire would have been. Yeah, but don't cheap out on tires, guys. Tires is what your vehicle is going to be riding on. So that's probably the only time that I actually agree with the salesman for the most part. If it's a better quality tire, if it's more durable, I don't mind paying for extra for that. Okay. Sorry, Henderson. What's up?
What's the side to buy?
Sine 2 pi is 0. We might do a unit circle quiz, guys. Yeah, because okay, let me tell you why. We have to be so good. If we don't know, okay, here's what's gonna happen. Later on, I'm gonna be doing derivatives, and I know you don't know what that is yet, and we're gonna be doing trig derivatives. If you don't know your basic trig, forget it. Forget trying to get an answer. Oh, you take a derivative and you got sine of pi over 6. What's that? Well, I don't know. I don't know what sine of pi over 6 is. You know what I mean? So don't worry. Just like last year, the first 3 won't be a grade unless you get 100. So we'll have a unit circle quiz if we're all available Friday, because tomorrow I want it to be your day. If we're all available Friday. If we're here, we'll have a quiz. If not, we'll have a quiz with whoever's here. But remember, it's not going to count. The first 3 will not count. Unless you get 100 right off the bat, then we'll count it. So we'll only take 1 grade. So all this quarter, we'll keep giving you unit circle quizzes. The highest grade you get. If you get 100 one time, there it is. You got your 100. I would still like for you to take the other quizzes. It won't count against you, just so you can stay fresh with your unit circle. Does that make sense? Okay. All right. All right. Here we go, guys. From the CED. These are real questions from the AP. Look, I'm so excited. Remember that special question? We'll see if you guys can get it. Don't worry. Even the BC thought it was hard. Take 1 minute. See if you can do this question right here, guys. Not this year, no. It's okay. All right, guys. Give it a shot. Give it a shot. Give it a shot. Remember, it's a limit, guys. So don't let it get you. Don't let it get you scared. You got an answer, Miss Kyle? Oh, you fast. Too fast, too furious. How many think it's A? Okay. How many think it's B? How many think it's C? 1, 2, 3, 4, 5, 6, 7, 8. How many think it's D? How many think it's E? How many have no clue? Okay. Let's see, guys. There's more than 8 of you. There's 16 of you. So only half.
I think I'm just confused because I remember whenever we did it the first time, you had to do g of x.
Yeah, that's what we're doing first.
And then you put that in.
And you put that into your F for the next limit. So you evaluate the inside first. Limit as x approaches 1 over g of x. We're doing limit, not the function. What's the limit as x approaches 1 for g of x? 2. So then I go limit as x approaches 2 of f of x.
So it's 2. Oh, wait, 3. Wait, I read.
Do you see how we did it? Okay. Before we start this one. Yep. Okay. If you can get this one right, which let me tell you guys right now in advance, because I don't want you guys to get sad. So far, I've been giving this question to every group, every year. No one has gotten it right on the first attempt. Hold on, before you guys get started, I gave this question to teachers. And besides the teachers that had experience, because the teachers that had experience obviously got it right. The teachers that do not have that much experience, the teachers that have been teaching for 3 years or less, have all gotten this question wrong. This question was on the BC exam. It didn't come out on the AB. And this question that you're looking at was the hardest one for the BCers. Not Lagrange error, not series, not Not any of the BC topics. It was an AB topic that was hardest for them. What percentage of the BC got it right? Here it is. 9% of the BC kids that took this test, international exam, got it right. So I just wanted to let you know, if you get it wrong, which you probably will, relax. You're in good. You're fine. This is a hard question. Take a minute. See if you guys can figure it out. No one has gotten it right. Maybe you will be the first. How many think it's letter A? I'll give you guys an extra minute. Maybe I shouldn't have given you guys that speech because maybe you guys are going to get it right just by pure luck. How many think it's A? Two?
No, just tell us the answer.
Well, I don't know yet. I have to solve it. Actually, we still got more to cover, so we gotta continue. How many think it's B? One. Okay. How many think it's C? You think it's C? Two, three, four, four. How many think it's D? Oh yeah. Now you're gonna. If you answer every choice, then I guess. How many think it's E? Two. Well, I guess someone got it right at least because you answered every option. So I guess this will be the first time someone actually got it right. Let's see how to tackle it. This is a composite function. You see that 1 minus x squared? If I were to graph that, that would look like x squared, but going downward with a vertex on the y-axis, like this. And here is, so there's that equation. That's y equals 1 minus x squared. Cool? So limit, so we're going to do this as x approaches 0. So if I approach 0 from the left, notice I'm approaching 1, but I want you guys to notice that I'm approaching it from the bottom. Like, and look, if I approach 0 from the right, notice that I'm approaching 1, but from the bottom. Chop, what do you mean by from the bottom? My y value is 0.9, 0.99, 0.999, 0.9999999. I don't go above that value of 1 here. See? Do you guys see that? So then when I rewrite this, I'm going to write limit as x approaches 1, but from what direction? From the left, because I am going from the bottom. I'm approaching x equals 0. I'm approaching the y value from the bottom. Do you guys see that? So limit as x approaches 1 of f of x. So don't worry, I'm going to answer you. So then I come back to this. As I approach 1 from the left, what is it? Yeah, you got it right. But did you do that logic?
No, we didn't do the logic. I really was guessing. switch the inside equation around to negative x squared plus 1.
Yeah, you can do
And
that.
then I translated that graph. So I reflected it, and then I moved it up 1. And then they both met at
Reflected up 1. How'd you take care of the square though? You just squared everything?
We did it the same way. We expanded the equation and then we equaled it to 2. Because that's what it is. Mine is just right here.
I would have to look at it, guys.
We just we broke it up so we did x minus 1 and x plus 1.
I mean, that is a difference of squares, but
Yeah, and then we saw
1 plus x, 1 minus x.
and then plugged it in. Yeah, we saw that the limit for like 0 on the graph is 2, so you can equal it to 2.
I'd have to look at it, guys. It doesn't sound like 100% legit to me, but it probably what? Yeah, if anything, it has to be 1 plus x, 1 minus x, because it's 1 minus x squared, and it doesn't. Yeah, that's what 1 plus x, 1 minus x is 1 minus x squared. But it doesn't sound. I mean, if you take care of it on the inside, maybe, but I don't. It doesn't sound right to me right off the bat. Yes, guys. So here's the right way to look at it. I'm not saying that you're wrong. The right way to look at it is I'm looking at 1 minus x squared, and I approach 0 from the left and the right. I'm approaching 1, but notice that I don't go above 1. So I'm bounded. I'm approaching 1 from the bottom. So because I'm approaching 1 from the bottom, that's like approaching 1 from the left. Because all these numbers, all these y values, I'm approaching 0.9, 0.99, 0.99999, 0.9999999. See, I'm never going to, and then I hit 1, obviously, but I never go above 1. Does that make sense? Because you're bounded. You're bounded. So I'm approaching the y value of 1, but from the bottom. So if you were to do a scale, it's like, if you were to do a scale, it's like approaching 1 from the left.
Oh, okay.
You know what I mean?
It's slowly.
This one's hard. Relax. This one's tough. Look, only 9% got it right, guys. So relax. Yes. Well, they give you 1 minus x squared.
Yeah, but it's not
No, you have to do it. You know? Correct. That's why only 9% got it right. Okay, this one here, guys, put it down. This is on the UH quiz 5. Here's what you're gonna have to do. Your trig limits.
Hey, Chuck.
Yeah.
What time are you checking the attempts?
How many say it again?
What time are you checking the attempts?
Oh, probably not until Sunday.
Okay.
All right, here we go. It says it wants to know this limit. It goes limit as h approaches 0 of f of pi over 6 plus h minus f of pi over 6 all over h. It wants to know that limit. So I'm going to figure out what f of pi over 6 is. I'm going to come to the side. I'm going to write f of pi over 6 equals cosine of pi over 6. What's cosine of pi over 6? Square root of 3 over 2. And I also need f of pi over 6 plus h. Cosine pi over 6 plus h. Do you remember, you're going to need this, do you remember what cosine A plus B is from last year?
Cosine A, cosine B, minus sine A.
Yes, that's what I need.
Yes, you can.
Here we go. I'm going to write limit as h approaches 0. I'm going to put this one first. Cosine pi over 6 plus h minus f of pi over 6, which is square root of 3 over 2. All this is over h. Have I lost anyone? Chav, why are you doing that? Because they told me to. They told me to find this. This is your A. This is your B. Chav, what are you talking about? This A and this B for cosine A plus B. We still okay? equals limit. Oh, what's up?
Can we choose any value for h?
No, you got to leave it as h. Because h is approaching 0. If you can want to change the h to an x, like we talked about yesterday with, oh, I redid the notes without happy faces this time. So, did you see it? Did you see the whole thing? Did I explain it better? Okay. All right, here we go. All I'm doing is this formula, guys. Cosine pi over 6, and a little bit we'll replace the cosine pi over 6. Cosine h minus sine pi over 6. Sine h minus, that minus is this minus, square root of 3 over 2. All this is over h. Are we still okay? Okay. We all took pre-cal for a reason. This is a reason. Give me the reason. Who was that? Cardi B? Do you know what I'm talking about? She's so funny. Okay, anyways. What's cosine of pi over 6? Square root of 3 over 2. Cosine h. Minus, what's sine of pi over 6? 1/2. Sine h. Minus square root of 3 over 2. All this is over h. So catch up to there. I'm going to move these two like this. Since there's no equal sign, the signs stay the same. Chav, why are you doing that? Because I'm going to do something to them. Limit as h approaches 0. Square root of 3 over 2. Cosine h minus square root of 3 over 2 minus 1/2 sine h. All this is over h. So catch up to there. Are we still okay? What's up? Tell me. Okay, yeah, no, I'm giving you guys time. I'm going to start grouping them. Chav, what are you going to do? What do you mean? I'm dividing by 1h, guys, so I can group them however I see fit. I'm going to do these two and these two like that. So I'm going to write it. I'm going to use my limit properties. Here we go. I'm going to write limit as h approaches 0. Square root of 3 over 2 cosine h minus square root of 3 over 2 all over h minus limit as h approaches 0. 1/2 sine h over h. Say it again. Oh, I'm just using my limit properties, the difference. So I'll do a sign it over here. Don't worry, guys. I'll put it back. Limit as h approaches 0 of a of h minus b of h. If I have it like that, you can do this. You can break it up into 2. That's a of h, not a times h. That means a is the form. Okay, so you can break it up into limit as h approaches 0 of a of h minus limit as h approaches 0 of b of h. Those are just the properties that we learned from a few days ago. So we can separate it like that. You know what I mean? Are we okay? Okay. Kyle, you doing okay? Okay. So check it out, guys. There's a square root of 3 over 2 here. There's a square root of 3 over 2 there. I'm going to take out my notes from yesterday because I want you guys to see it. So open document. Everything written in class. Notes. Was it yesterday? Yeah, it was yesterday. Okay. Can I factor out a square root of 3 over 2? All right, so here we go. I'm going to write it like this. Limit as h approaches 0. Here's my square root of 3 over 2 over factored out. And if you want to put parentheses like this so you guys don't get confused of what's your argument, parentheses. Cosine h minus 1 over h, close it. And I still have parentheses like that, see? Minus limit as h approaches 0, 1/2 sine h over h. Yeah. I'm factoring out the square root of 3 over 2, and I'm factoring out the half. I actually wanted to pull the square root of 3 over 2 to the front of that, but I don't know how you guys feel, so I'll leave it like that. Are we okay? Okay. So check it out. Does that look familiar to you? H approaches 0 of cosine h minus 1 over h. Yeah. It's right. No, not the Valentine's. Look, it's this one right here. It's just a variation of it. 1 minus cosine x over x is 0. Notice will be a variable. So it's this one right here.
So it's interchangeable.
Yes. See, I have it right here in the. I thought I did it, but I did a better job. Watch my notes again, my video, and I think I explained it better the second time around.
So okay, so since it's a sine. Okay, okay.
So I'm gonna use 1 and 2.
So does that only work if it's approaching zero?
Yes. If it's approaching infinity, the bottom just has going up and down, up and down, up and down. The top goes up and down, up and down, up and down. Bottom keeps growing faster. So if it was approaching infinity, it would be 0 for both. All right, here we go. You guys ready? So this right here that I'm circling is just what? So I have square root of 3 over 2 times 0. Say what? Yes, just 0. Just that I circled, right? Minus 1 half. And what is this? Sine h over h as long as h approaches 0. What is it, Kyle? Yes, it's 1.
So all that for negative half.
Yes. Later on, we'll take shortcuts. Right now, we're going to have to do it this way. For those of you that have the sine one instead of the cosine one, let me write that one down. You know what? I'll put all of them in here. I'm going to put a plus minus like that. So then I put a minus plus. So if you have an a minus b, you use the plus one. If you have an a plus b, you use the minus one. Let me put the bottom one instead of sine. Instead of cosine, I'm going to do the sine. What is sine a plus minus b? Do you guys remember? Sine a cos b. And because I put plus minus, I'm going to put plus minus cosine a sine b. Guys, write this down. You're going to need it for your UH trig 5. Later on, you can do a shortcut, but right now we have to do it this way. Try not to use AI, guys, because AI is going to tell you that it's a derivative, and we don't know that yet. Yeah, we don't know. We don't know derivatives yet. You don't. As a matter of fact, pretend you didn't even hear that word. All right, we're almost done. I'm not sure. Well, we'll do it all. All right, guys. This is not on AP. Child, why is it in here then? Because UH is going to ask you this question. This is like error. It's epsilon. It's a small epsilon. This is a delta. Child, delta is a triangle. It's a small delta. The triangle is a capital delta. You guys knew this, right? No? Okay. Now you know. Now you know. It's a delta. Child, deltas are triangles. It's small delta. Small delta. Like capital A, little a.
So it has no real difference whenever you're actually multiplying.
No, I mean it means something different because it's not, you know what I mean? Like it's just a variable like x and y and theta and phi. Did I not answer your question? Okay, ask me again.
Okay, I'm asking like what's the difference between regular delta and small delta, and what are the like different properties or like values?
No, the capital delta many times is used to indicate change in, but it doesn't have to mean that. Different textbooks will use delta differently. You know, they might say something else. Statistics, they might use it differently. But in the math world, capital delta, the triangle, is meant for the change in. Small delta, it can be used many different ways. Like, you know what I mean? This is epsilon. It's used to indicate error in this case. But later on when we get into BC, you're going to see capital delta, the summation symbol, and that's going to stand for sum, like to sum everything. So it just means different things, just depending on what the author wants it to make. You know what I mean? Don't worry. Yeah, you're fine. Okay, you guys okay? All right. So all this means is how close. What does it mean? How close must we get to x equals 2 so that the error is 0.01? That's what it means. That's what your delta, the small delta means. How close do I have to get to it so my error can be 0.01? The error from what the real value is. You know what I mean? No? Okay. So you see how I have x over 3 here? So you just go x over 3 minus 2/3. And I want this error to be less than 0.01. The error on how close I can get to the 2/3 there. Are we okay? No, you're good. Miss, I want you to ask. Ask. So here we go. I'm just going to do this. X minus 2 over 3. What? Yeah, what's the answer? No, I think it's 3 100s. Right? I'm gonna multiply by 3. Yeah, but I need to get it. I need to get x minus 2 by itself, right? Because I'm approaching 2. So I'm gonna multiply by 3 times 3 times 3. So I'm gonna have x minus 2 less than or equal to 0.03. Stop right here. This is your answer. I know, guys, I'm not going to ask this question on the exam. If they wanted to know the x values, how close must you be? You would have to be between 2.03 and 1.97. Your professors are going to want that. Yes.
You multiply by. No, I got it.
Yeah, multiply both sides by 3. Oh, because I want the error to be 0.03. I can be above or below the 2. You know what I mean? Yeah, you're always trying to, in case you don't know what I'm trying to do, guys, you always want to get it in terms of x minus c, where c is your x value that you're approaching. What's the question, Miss Houston? Hit me. Oh, you're good? For sure. Yeah, this question you're not going to get asked, but your professor might ask you. It's not going to be on the AP, and it's not going to be on my exam. It is going to be on UH if you want to get the question right. And again, that's a demerit. I'm not going to write a demerit. We're okay, guys? All right. Then we get to these questions. I think you guys are good now at these. These are one-sided. These are pieces. Hopefully you're kind of decent with piecewise functions. This means I behave like 2 minus x as long as x is less than 1. I behave like x over 2 plus 1 as long as x is greater than 1. So letter number 1, it says x approaches 1 from what direction? The left. So am I going to use formula A or formula B? A, because it's approaching from the left. What's 2 minus 1? 1. There it is. Do you see how we did it, guys? All right. Letter B, or number 2. Limit as x approaches 1 from the right-hand side of f of x. Which one am I going to use, A or B? B, because I'm approaching from the right-hand side. So I'm just going to plug in a 1, direct substitution. What's 1 over 2? Half plus 1? 1.5, which is 3 over 2. The next letter, I should have tried to fill it in this one. It just says, what's the limit as x approaches 1 for that same function? Well, from the left it's 1, from the right it's 3 over 2, so this one is? Good. What is f of 1? Well, if I plug in a 1, which one do I use, A or B? A. Why am I using A and not B? Because there's an equal sign down there. So 2 minus 1 is 1. So there it is. See, so you guys are good at these. All right, squeeze theorem, sometimes called sandwich theorem. It does come out. It came out actually kind of recent, and you don't necessarily have to reference it. You'll see what I mean when we talk about the free response. Maybe it's kind of silly on this one to use it, but I'll show you what we mean. So it says to show that the limit of x approaches 0 of x squared sine over 1 over x equals 0. All right, so I'm going to write the expression x squared sine of 1 over x. From your pre-cal days, we know that sine is just going up and down, up and down, up and down. Here's 1, here's -1. This is just sine. Yay or nay? This x squared in the top acts like a amplitude. Yes or no? So if I have an x squared in the top, this whole function, all of it, will never be bigger. What's the biggest it will ever be? I don't know. You guys know what I'm talking about? Okay, let me make something up. 3 sine x. 3 sine x will never be bigger than what? 3. It will never be smaller than negative 3. Do you guys understand that? Okay, let's go back to this one. So this sine 1 over x will never be bigger than x squared and will never be smaller than negative x squared. So do that. And make sure to write with words what we just talked about. So you can know what we're talking about. Like this, I would say x squared acts like amplitude. So the biggest x squared sine 1 over x will ever be is whatever x squared is. X squared is like amplitude. Okay. I want you to observe something, guys. So here's what we're going to do. You see this curve right here? That's y equals x squared. You see this curve down here that's opening up downward? That's y equals negative x squared. Do you see this curve that's going up and down, up and down, up and down? That one is x squared sine 1 over x. Do you guys notice or observe that the x squared sine of 1 over x is sandwiched or in between x squared and negative x squared? Yes. Okay. So what is this limit approaching? 0. So because it's in the middle, so here's what we're gonna do. I'm gonna go limit as x approaches 0 for x squared. I'm just gonna find this one first. So can I do direct substitution for this one? Limit as x approaches 0 of x squared. What is this limit? 0. Now I'm gonna do the one on the left, the negative x squared. Limit as x approaches 0 of negative x squared. Can I do direct substitution again? What is this limit? 0. Okay. I'm going to slow down. I'm going to go really slow. Because the expression x squared sine over 1x is right smack in the middle between negative x squared and x squared, this limit by sandwich theorem or squeeze theorem must be 0 because the both extremes are 0. And since this is in the middle, this has to converge to 0 as well. And you can tell by the picture, look at this picture. The parabola, for the parabola x squared as x approaches 0 is 0. This one down here for negative x squared as x approaches 0 is 0. Oh, look at this curve here, the sandwich one. Look, it's converging to 0 because I'm being squeezed in or sandwiched in. Does that make sense, guys? So that's what we would write. So I'm going to say, by squeeze theorem, comma, limit as x approaches 0 of x squared sine 1 over x must equal 0. And make sure you have these two limits on the left-hand side because that's how you use squeeze theorem. The rightmost is 0, the leftmost is 0, so the one in the middle must also be 0. Yeah. How do we feel? Okay, we got about 20 minutes left. I know that's not a lot of time. Relax. Tomorrow, you have all of lab for yourself for the exception of like the first 5-10 minutes because we want to go over some questions just so you can see that we got this. So you don't have to worry too much. If you want to get ahead of the homework, try to finish it all. That's fine. UH quiz 2 limits 2 we're now in full force. We can do it. UH quiz 5 trig limits, we're now in full force. We can do it. Before you start the quiz limits, get some experience with delta. Delta gives you feedback. So do the delta math first. That way you can get experience, and now you can tackle the UH. UH don't give you feedback. Quiz 1 is due Sunday. Quiz 2 is due a week from today. So what's today? Wednesday. So due next Wednesday, and quiz 5 is due on Wednesday as well. Timeout. There's a video. I have videos for all of them, guys. Do you guys know how to find my videos? Okay. If you are okay, time out real quick, guys. If you keep getting the same questions wrong over and over, let's say you've taken it 3 or 4 times already, and you keep getting them wrong, guys, stop taking it. You're just creating you're just creating more stress. Stop taking it. Come in, and when you come in, say, Chop, I've watched your videos. I've taken it 4 or 5 times. I keep getting them wrong. Can you help me? And we'll go over it. But please watch my videos first. Maybe that will take care of the issue. Don't just tell me that, like, I watched your video and then you didn't watch it. Tell me that because you did watch it and you still don't get it. And then we go over it. Does that make sense? All right, guys, have at it. You got about 20 minutes and see how much delta you can do, and then we're done.